find the critical value for this problem. It doesn't ask me for it, but I'm just going to find it, okay? So this is finding a critical value. If I were to use the formula, I'll write the formula here too, but you need to know how to find your critical values. And in this particular example, it's a 90% confidence interval. So I need to know the confidence level. So 90% confidence level. And you guys will see me use like some abbreviations. For me, I use CL for confidence level, which is 0.9. And just like last week, we're going to need alpha. And alpha is always the complement of the confidence level. So I always find alpha by doing 1 minus the confidence level, right? And because it's a confidence interval, right, you kind of have two ends of it. So the 90% is like in between 0.9. And so you have the 10% left over in both tails. So I have to split it in half. Half goes in one tail, half goes in the other. I don't know if I'm touching something. I got to figure out why it's doing this, tripping. So we always do alpha over 2 when we're doing confidence intervals, which in this case is 0.05. You want to determine if you're on a SND curve and dealing with z-scores, or you're on a t-distribution and dealing with t-scores. And the nice thing about proportions, and this is why I like to do proportions before means, but this book for some reason goes in the opposite direction, because anytime you're dealing with proportions, it's always z-scores. Anytime you're doing proportions, it's always z-scores. You're only doing t stuff if you have a mean and sigma's unknown. That is the only time you're dealing with that. Other than that, it's z. So if I have proportions, my life is easier because I'm automatically z. Okay, automatically on an SND curve, automatically z-scores. Okay, automatically, you know, this is 0.5. This is 0.05. I always find the right-tailed critical value. You could find the left-tailed and just make it positive, because if you're asked for the critical value, we always take the positive version of it. And it's always inverse norm if I'm doing z-scores. Okay. Inverse norm, if I have the area to the right, like this one I'm finding, this is when I do that 1 minus, and then 0 and 1. So here. Let's go to the calculator. For critical values, you're doing second vars. So I told you guys, if you've been coming to my stuff, you're living in stat all day, or you're living in second vars all day. That's like the foundation of this course. It's like stat or vars mostly, right? So if I'm doing critical values, which is what you need from now on, this week and I think either the next 2 weeks when you do hypothesis testing, it's second vars for critical values. And if I'm doing a z-score, it's inverse norm. If I'm doing a t, it's inverse t. Z-scores always go with proportions, inverse norm. Not everybody has this here, like if you're doing the app, which I have here, second vars. Oh, it's frozen. If you're doing the app, it's automatically area to the left. You don't have this option, so you would do the 1 minus. Right? This is me over here assuming you don't have the option of this left, center, right. And then, you know, if you're on an SND curve and you're dealing with z-scores, it's always 0 and 1 for mean and standard deviation. And then my critical value is 1.64. So my notation is z alpha over 2. That's what it looks like. 1.645 if I'm rounding to 3. Okay, so that is the critical value notation. It's a z critical value with this area in the right tail, and that value is positive 1.645. If you guys have the option where you could tell it where the area is, you just tell the area 0.05 and you say area is in the right, and then you go paste and you get the same thing. It doesn't matter, right? But if you don't have that option, then automatically your area to the left, okay? So wait, let me pause or stop that recording again, because that was all I wanted to do with that one with critical values.